The next session focuses on businesses. The three businesses we're going to hear from were all founded by people who came with existing business skills into the field of sustainable energy. And we need with other people with these developed business skills to do the same. They're very different businesses, they do different things, they're in different parts of the world, but they have all come in from a very, very clear commercial basis. The first we're going to hear from is Ekami, which is a family business in Nicaragua, founded over 20 years ago, and we'll start with their film.
In Nicaragua, almost a third of the population lives without access to grid electricity. But with 300 days of sunshine a year, solar energy provides hope for even the most remote communities. Ekami has been working for over 20 years to harness the power of the sun and bring electricity to those that need it most. Started by Luis Lacayo in the 1980s, Ekami began by installing solar systems for radio communications after Nicaragua's civil war.
We had to look for alternatives for the energy we needed. We started to bring in solar panels. We had only heard about them. We started making people aware of this technology. We were the pioneers in Nicaragua.
His son Max has joined the family business, and he's keen to see it grow.
Well, my father brought the first solar panel into Nicaragua. That was around 20 years ago. Today, 20 years later, we're installing more than 1,500 solar panels per year.
Ekami installs solar panels across the country, from single panels on small homes to large-scale systems able to pump fresh water to entire rural communities.
The water we have here comes from wells, but it's not drinkable. We don't have electricity either. The nearest city is about 25 kilometers away. Since the solar panels were installed, we now have drinkable water. We can take proper showers now. We can wash the dishes, wash vegetables. I can shower my children as well. I think that it is very important that we have drinkable water.
This solar array provides enough power to pump water directly to 80 homes. Ekami has trained a local committee to maintain the system. They tilt the array to maximize capture of the sun's rays.
After the systems are already installed, we teach them, me and the engineers, how to do the maintenance, because the whole idea is to make the system self-sustainable, and teach the community how to do the maintenance. It's an important part of that.
Jairo Velasquez has been working as an Ekami engineer for over 12 years.
The beauty of solar power is that it's accessible and it's easy to use. You are in touch with the communities, with the people that need your services, to teach them how to use the system and to be part of the solution. To be part of the solution is the most important part of this job.
We had our doubts that this apparatus would create the energy we needed to pump the water. But when we saw it working, we felt happy and relieved. She used to carry it in a bucket on top of her head and bring it to the kitchen. Now we have it here.
The introduction of piped fresh water has significantly improved the health of the community.
Por el beneficio del agua, hemos tenido una reducción de enfermedades.
Because of the better water, we've seen reduced incidences of diarrhea and vomiting. It's been proven that this community has the fewest numbers of visits to the health center for these illnesses in this area. And so, we hope that this project expands.
Y esperamos que el proyecto se amplíe más.
Solar panels have also been installed to power rural health centers.
Before the solar panels were installed here, we didn't have a fridge because there is no grid electricity in this community. Now we can have vaccines here permanently because we have a place to store them. This means we can keep children up to date with their vaccines. There is nothing we cannot do because of the lack of energy.
The solar panels are more than just electricity. Solar panels means bringing help to communities where they have a lot of poverty.
Today, Ikami has installed over 5,000 systems in homes, schools, hotels, community centres, even a mobile phone mast.
In rural areas where there is no grid electricity, solar panels can make a huge difference in the quality of life of the people and the families that live there.
I'll now hand over to Max Lahayo. Max is the son of the founders of Ikami. He's now joined the family business as marketing manager, and he'll tell you about their work today. Max.
Thank you. Well, good morning, ladies and gentlemen. Thank you, Ashden Awards, for this beautiful opportunity that we have to show a little bit of our job. So, in Ikami, I said that we came from a radio communication company to a renewable energy company. My father set the business during the 1980s, and he worked with radio communications. Nicaragua was still in a civil war, so most of the power lines were destroyed. So he came with the idea of installing solar panels to power radio bases. And I'm pretty sure that by then he didn't realize how these solar panels were about to change his main business. Here in this picture, we can see my father in the 80s explaining the former president, Daniel Ortega, which was a general by then, how the solar panels work. Over the 20 years, Ikami have made installations all over the country. So in this map, we can see, this is Nicaragua map. You can ubicate it in the middle of Central America. And we have installations all over the country, and also we have make installations in some rural communities in Honduras. Why renewable energy and rural applications are so important in our country? Because approximately only 57% of the people have access to the electricity grid. Also, in rural areas, around 23% of the population have access to electricity, and there are people that are not going to have electricity from a grid for at least 20 years. And also, renewable energy are very important because most of the electricity from the grid in Nicaragua is produced by fossil fuels. So we have, I think, the most expensive kilowatt hour in Central America. What we do is that we are a private company, and we design and make installations of renewable energy systems. But a very important part of our job is to involve the community. And we always try to teach the community members how the system works, so they can do the maintenance and they can rely on these type of systems. Well, we have a very diversity applications, because we install from very small PV installations in very difficult places. So you can see this is one single solar panel that we had to take across a river. They're carried on by shoulders or even the donkey of a member of the community. So these people can have 6 bulbs in his house, also charge his cell phone and maybe watch TV. But at the same time, we install and design high tech systems for telecom companies that bring signal to rural places. So now the farmers are able to charge their cell phone, but they also have the signal, which is required for that. We do also a lot of work with NGOs, and also help a lot of the Minister of Health installing vaccine refrigerators. You can see we have a refrigerator for vaccines and also for blood. And in some cases, health centers can look after 2,000 people. They don't even have a road together. For example, these refrigerators have to be taken by a boat. But also, we do installations in the middle of the city because a lot of companies or NGOs and buildings are willing to reduce their energy bills, but also have energy backups. We also work with solar water heaters from a single home to hotels. We do water pumping for a single farmer, or we can do a water pump system for an entire community. We work also with wind turbines, from very small wind turbines to mid-sized wind turbines, also vertical axis wind turbines. And the benefits that we can quantify, it's that we have installed over 10,000 solar PV systems, around 450 kilowatt peak, in 5,000 families. We have water pumping system that have taken potable clean water to more than 800 people, and we have set 3 branches in the country, and we have been able to create 8 entrepreneurs that work as sellers and distributors in different regions in the country. So the next steps for us, we're willing to install around 180 kilowatt by the 2009-2010, and we think that we're going to install more than that right now. Set more branches in the country, also introduce new technology to improve the efficiency of our system, and we're willing to start a microfinance program to give loans for renewable energy system that can improve the agricultural productivity in rural areas. Okay. Well, thank you for listening.
Thank you very much, Max. We're now moving to Africa and to Uganda. And we'll hear from a Ugandan entrepreneur who's actually set up and run quite a number of businesses. His latest venture, it was motivated actually by the need to find a cheaper fuel for his coffee roasting business. So we'll first see the film of the briquetting work of Kampala gelatone suppliers in Uganda.
In Uganda's capital city, Kampala, almost everyone uses firewood or charcoal for cooking. Tons of it is used every day in businesses, institutions and homes. The impact it's having on the surrounding countryside is clear to see.
All this area you can see was covered with trees, and as you can see from the far end here, all this has been cut down, and we have a fear the desert might come to Uganda.
Abasi Musisi owns a coffee roasting business. Keen to find a cheap and sustainable fuel, he came up with a very practical idea. Fuel briquettes made from sawdust and agricultural waste.
We had a lot of sawdust from the furniture workshops around Kampala. They had a problem of taking that one away. They were paying some people to take it away. And even for the agricultural wastes, they were being burnt. And that was a hazard also. So when I considered all those aspects, I said no, something must be done.
Today, Musisi pays carpenters and farmers for their waste products. Sawdust, rice husks and nutshells are just some of the many materials he buys. The material is sieved and then dried before being mixed together to make the perfect briquette.
Each material has a different characteristic. We mix them together like a baker makes a good cake. We do the blending just for one reason, to have a standard briquette. With the firewood, you have different species of wood. But with our briquette, it is standard. We'll give you the same firing today, tomorrow, and day after.
The mixture is fed into one of 2 briquetting machines. They compact the material into convenient blocks. Musisi was soon producing more briquettes than he needed, so he started persuading other institutions and businesses around Kampala to install efficient stoves to burn briquettes. One of the first to try them was a local confectionery company.
We first built one stove just for a trial and worked out. This is a great idea because when I look at the composition of the briquettes, these are waste materials and we are rich in waste materials. I don't see any reason why we should continue using, cutting or firewood and so on.
Not only the briquettes helping to save the forest, but they could also save lives. Smoke is a major cause of respiratory disease, and the briquettes produce hardly any. That's good news for the cooks that spend all day in the kitchen.
When we were using charcoal, the fumes used to make us cough, and many times we would end up ill. But ever since we switched to briquettes, we haven't had any trouble because there's no smoke giving off. We no longer feel sick the way we used to.
Several school kitchens also use briquettes. This one caters for over 3,000 pupils every day.
Before we used to use charcoal. Really, we could prepare food and it takes a lot of time. But this time, 11:30, food is already been served. So that's how we have now really known that really these briquettes are really faster.
The briquettes are also much cleaner to use. They're easy to store and they don't need to be chopped up. And the new stoves ensure that most of the heat stays where it should.
It used to be very hot. Ever since we started using the briquettes, with their briquette stoves, the heat reduced. So you find that the heat is just like you are just in normal rooms, like you're in the office. So you just enjoy preparing food.
The word is spreading. Kampala Jellytone now supplies briquettes for over 1,000 stoves across the city. And it's not just big businesses and institutions that can benefit. It could transform the lives of thousands of people who still burn firewood at home. Kampala Jellytone are now working to develop an efficient domestic briquette burning stove.
It is my prayer that we may continue to use them long into the future because they have been a great help. I have nothing but praise for briquettes. They are 100% excellent.
100%. We are now serving the country or the world.
There has been a need for someone to come and intervene in the situation. And I'm proud Kampala Jellytone Suppliers is a leading in this area.
I'd like now to introduce Mr. Abasi Musisi, the Managing Director of Kampala Jellytone Suppliers, to talk about their work. Musisi.
Dear guests, ladies and gentlemen, all protocol observed, please accept warm greetings from Uganda, the Pearl of Africa. My name is Mr. Abasi. I'm the MD of the Kampala Jellytone, the company that converts agro waste into fuel. We started our research way back in 1992 after realizing that the prices for oil was going up and consequently the price for gas and electricity was going up. So we had to look for an alternative just to fuel our coffee roasters. And as you know, biomass briquettes are an alternative to wood fuel and charcoal. As it is for most developing countries, also in Uganda, 91% of the population are depending on food fuel from the forests, that is wood fuel and charcoal. And these people are quite ignorant about the dangers of deforestation, so they just cut the trees anyhow. And there is a fear that maybe in the near future we might get to experience the desert. So we came to realize that there are so many agricultural wastes around us. 1.3 million tons of waste are produced every year in Uganda. And Those were just a few of them. We have about 30 crops grown in Uganda, and they all yield agro wastes. We had to intervene, first of all, by getting into research in the biomass which could come up with a good briquette. Then also, when we made the briquettes, we had also to go in search for an appropriate stove, and we had to get the right technology of making the briquettes. And when these briquettes were made, it was found out that they had so many advantages over wood and charcoal. We had to improve the stoves. We had to build also domestic stoves. And we had to sensitize the people, the outputs. In the last 5 years, since we started commercializing our product, we have been able to build over 1,300 stoves, and those we have supplied to institutions, factories, medical hospitals, and in homes. And this has attracted over 5,800 tons of briquettes sold, which is an equivalent to 6,900 tons of firewood that would be used if we didn't come in. And this will abate about 35,500 tons of carbon dioxide. What are the benefits? I think we have contributed largely on indoor air pollution, deforestation, and as you have noticed from our film, the cooking is faster, it is environmental friendly, and of course, we are trying to get carbon credit, and I think we qualify for that. Because as you may realize, our trend is going up. From 2005 to 2009, we are almost tripling our production. And the schools are quite clean. All our end users are enjoying the cleanness of the briquettes. What are the next steps? We are trying to mobilize funds. We are trying to, for the research, so that we come up with a better product. And we want to sensitize more people. And we need more assistance in terms of technology improvement. And we want to replicate our strategies to various places of the world. We would also want to attract the government to come up with a policy that will address us as briquette makers. Because right now in Uganda, there are only policies for firewood and charcoal, and nothing for briquettes. Thank you very much.
Thank you very much indeed. Finally, back to the UK, and actually under the ground. I'm pleased there's a bit of the underground that is working today, and that's the underground supply and rejection of heat through geothermal heat pumps. Heat pumps are a technology that can be used to provide sustainable heating and cooling. And the next film that we'll see shows how Geothermal International have specialised in providing such systems, particularly for large commercial buildings.
Well, Geothermal International is a company which uses the ground as a source of energy for heating and cooling buildings to really lower the carbon footprint of the buildings we're involved in. The idea of ground source is to exploit the very even temperature you get in the ground. The ground in the UK is pretty constant at 12 degrees C, and it's that constant bath of energy that we are using in ground source technology. The technology was really invented with the heat pump. The heat pump is simply a device we use to move heat from a cold place to a hot place. The technology to put pipe in the ground, which is our heat exchanger mechanism, has improved dramatically over the years. Typically we find, certainly for larger commercial buildings, the payback for the cost savings alone can be as short as 3 to 6 years. As the buildings get smaller, then the savings proportionately get smaller. By putting cold water into the ground will naturally warm up that water, and so we're extracting heat. Now similarly, to cool the building, we can put hot water into the ground, and naturally it will then cool as it flows through the ground. By moving heat around rather than burning fossil fuels to create heat or using air conditioning units to just simply dump heat into the atmosphere, then we get an incredible efficiency advantage over conventional equipment. Cavemen lived in caves because they were nice and warm in the winter and nice and cool in the summer. So really, ground source or geothermal technology is very old. Well, the initial concept for an energy pile scheme is to use the holes that are being drilled anyway to support the building, to use those to put pipe in. It's a very cheap way of putting that pipe in the ground. Geothermal technology does require electricity to run it, so there is a cost to move the heat around between the ground and the building. I think the key point is that it moves an awful lot more energy around than it consumes. The concept is that we simply use the holes that are being installed. They're going to be filled with concrete. We simply put some pipe in it first. We should have been doing it an awful long time ago. As the focus on the environment and indeed on fuel costs has increased, then the spread of the technologies is almost inevitable, really.
They're connecting up the pipework by the process of electrofusion, which involves putting it together, taking a barcode reading off the fitting and basically just fusing the joint together.
As a heat source, gas is about 80 to 90% efficient, but using ground source, we are talking maybe 400 to 500% efficient. So for every kilowatt we are buying, we are getting 4 to 5 kilowatts put into the building.
I'll hand you over now to Patrick Sheriff, the Marketing Director of Geothermal International, to talk more about their work. Patrick.
Thank you, Anne. Good morning, ladies and gentlemen. Geothermal International have been in this business probably longer than anyone in the UK, and the business is based in Coventry. We're an engineering-driven organisation, and we specialise in primarily commercial buildings. 80% of what we do are new build. The retrofit side of the business is growing as confidence in the technology starts to grow. Little unknown fact, but we have installed over 100 megawatts in the UK alone in heating and cooling capacity, which roughly is 5 times the entire UK solar industry, which gives you an idea of the scalability of this technology. We employ over 85 full-time engineers, and we are growing into Europe. The success of the business has primarily been the fact that we've concentrated on providing a turnkey solution to the construction and consultant or new build industry, and that's really from feasibility right through to maintenance, warranty. We will warrant the system and the output of the system, which is a cast iron guarantee to any new or any client who is being introduced to this technology. The business has got to a stage where we're turning over 12 million, and it's got to a stage where we're attracting some quite large strategic partners. This is significant, I think, in terms of for the UK, in terms of the likes of a major utility like Scottish and Southern, major construction companies like Skanska, partnering with innovative and pioneering businesses like ourselves to get this technology out onto a mass market. The reason that we've attracted these types of partners is the pioneering approach that the business has taken to ground loop design, particularly for heating and cooling, and thinking out of the box beyond boreholes, but actually looking at other ways that we can extract heat from water, from the sea, as well as from energy piles. Systems and case studies. This schematic really shows you the different areas that the company specialize in. Open loops to closed loops. Closed loops are the most common type of system that we use, and really that is boreholes and energy piles. We've done a lot of work, and you'll see in the case studies in central London, which is really, the fact that we haven't had the luxury of working with lots of space. We've had to think of other ways of looking at the footprint of the building to extract heat and for cooling. My first case study is Gloucester Police. This is a PFI project. It was installed in 2005. It was the largest, and it still is one of the largest closed-loop systems in the UK. Note the heating and cooling loads on all these case studies are quite evenly balanced, and that allows us to design a very efficient ground loop in terms of what we're taking out in the winter we can put back in the summer. This uses the ground in an efficient way, and it means that we have to put less pipe in the ground. The performance of this particular installation is been verified by the building services company, and we're saving over £60,000 on run costs, and we're achieving COPs or coefficiency of performance of above 7 now. So that sort of efficiency through heating and cooling with technology can be achieved if the building is well designed, well insulated, and the system that we put into the ground is compatible and works efficiently on the control side. Mansfield Hospital, we have just commissioned this system. This is the largest lake loop. We're using plate frame heat exchangers, which we dropped into the nearby reservoir, and it's the largest of its kind in Europe, possibly the world. We're just going back to get that verified. We're doing all the cooling for this hospital and a third of the heating. This is the largest system in central London, which you saw on the film. The benefits or the drivers here were, and the reasons that Land Securities went for this technology above any other technology, was the fact that we could utilize the energy piles and an open loop system underneath the building. My last case study is Embassy Court. This is really an example of a mini district heating scheme where we put all the pipe in piles and boreholes underneath the footprint of the building. This is in North London. And we're going into a central plant, and from that rises up into the apartments. The way forward for Geothermal International is continue pioneering the sector within the commercial sector within the UK. I think that government legislation, renewable heat incentive, will help to take it to the next stage. And lastly, we're looking to replicate this business model in key European territories. Thank you for listening.
Thank you very much to Patrick. I'd now like to ask Patrick, Musisi and Max to come for questions here. And I think Chris Davidson from Geothermal International, who starred in the film, will also join Patrick. Yes, good. Question for Max. How do people in Nicaragua afford to buy a solar system?
We have a lot of poverty in Nicaragua, but we also have some improvements in the agricultural areas. The population is trying to get access to microfinance. So we're looking forward to working a lot with NGOs like GENDESEN and also with some MFIs. But most of the people are not able to afford a $500 to $600 system. That's correct. But also, this is why we're looking forward to improve our technology to work with smaller solar panels, so the system will have a lower cost.
And do you want to mention LED lighting?
Yes. Well, for example, right now we're working with 40-watt solar panels to 130-watt solar panels for rural installations. But now introducing LED lighting to our system, we'll be able to use 10 to 20 watt solar panels. So the cost will be reduced in a big sector of the population will be able to purchase one system.
Thank you. So the question is again to Max. Does Economy offer end user finance, and what sort of terms does it offer it on?
Right now we have several islands with MLIs, but Economy itself is not providing loans. Actually, we're willing to establish a loan project starting with the money of the Ashden Awards. So we have already contracted some consultants that are going to help us to operate this small office that will allow us to give small loans to customers. But we also are getting in contact with NGOs and JSM to give us a subsidy for the system we're going to give loans.
Thank you. Okay, again for Max, what proportion of the business is directed at water pumping?
Right now, water pumping is still a small proportion of our business. Most of the installations are requiring electricity and illumination. But we're willing to have a cheaper technology, because solar water pumping system, but also wind system are still very expensive for people in rural areas. But we work for a very small system for 500 liters per day to a system of 10,000 gallons per day with wells of 100 meters depth.
Thank you. Yep. So to geothermal, are you looking at expanding so that you can provide a complete building solution?
Well, we ourselves are not. To be quite honest, we have our hands more than full supplying the geothermal market, the ground source market in the UK. But I think as part of our strategic partnership with Scottish and Southern Energy, who are one of the largest renewable energy suppliers in the UK, and we do, believe me, push them very hard to increase their renewable energy capacity. We are hopefully making some kind of difference.
Thank you. Okay, so on briquettes, how much could you scale up in Uganda? Would you be able to eliminate all use of firewood with the agricultural waste that's available if you briquetted it?
Thank you very much. First and foremost, I have seen our presentation. There is quite a lot of residues around, which is being now banned with no use at all, and claiming they're trying to utilize all that. And for information, all the people now, most of the schools and industries are using either wood or gel. So all those are our potential customers. And of recent, when we started supplying the schools, so many schools are panicking now. And we only try to put down our order because we cannot supply them as of now, because our production is still restricted. So that's how I would say. And I think the policy is coming in now to address this issue, right through the Ministry of Energy, together with the First Department. So the market is very good, and when we have to invest a small version. And unfortunately, they are looking at it because there was no interest. I was trying to say, people were interested from the government about the wood and the gel. And our briquettes fall just in between. So there's a room for improving that.
I think you did mention yesterday the total amount of residue that's available in Uganda.
Statistics of 2007, Uganda produces 1.3 million tons of residues, agricultural residues. And all this will be converted into briquettes. And these briquettes, if we give them out, they will probably satisfy a little fraction of the schools around this. Right now, we're supplying all the schools around Kampala. And not all the districts, but one of the districts.
Thank you very much. Okay, so the question to geothermal is, what could the UK government do to promote this technology more rapidly? I should just perhaps say that this evening the UK finalists will be having a dinner arranged by the Ashden Awards with UK policymakers, so this can be a dress rehearsal for Patrick for what he's going to say this evening.
One of the things I didn't mention in the presentation was one of the drivers for our business has been the Merton rule, which you may or may not be familiar with, which has really initially covered central London and surrounding London. And if that could be adopted around the UK, that's a driver for certainly new build to not really get planning until they've got at least 10, 20, if not more, % renewable content in terms of energy in the building. And then I mentioned very briefly the renewable heat incentive, which the government are looking at, and we are aware that heat pumps are, alongside other low carbon heat technologies, are being considered within that. And I think that certainly the lessons learned from countries like France and Italy and Germany, and to a lesser extent Sweden, the sort of level of tax or grant that you're looking at has to be between 30 and 50% for this technology to be widely adopted. Of course, once the market starts to take off, costs will come down. So there'll be a meeting somewhere in between.
Thank you. Okay, so two questions. Are heat pumps viable if they're just used for heating? And secondly, what's the smallest heating load you can go down to?
I'll take that question. Yes, they are viable for heating only. The difference between a heating and a cooling system, as far as the installation is concerned, is practically nil. So you almost might as well do cooling. I wouldn't want to think that we as a company are encouraging cooling. We certainly don't want to encourage cooling where it's not required. But certainly where cooling is required in a building such as this, it makes an awful lot of sense. So that tells you a little bit about where we certainly think the market is. It's certainly heating and cooling buildings where there's a native requirement there anyway. In terms of how big does a building need to be, well, we as a company certainly found the bigger the better. However, we do install small systems, and we do install systems as small as, one of the slides there is about 6 kilowatts, is about as small as we get. What you will find, of course, in a modern building is when you do get that level of insulation and you need such a low heat loss, then actually the domestic hot water requirement is often larger. And so to size the system then on the domestic hot water requirement has its own challenges. But certainly give you more information if you want to catch me later.
Thank you. Okay, the question is, can rural communities afford briquettes if their firewood would be free?
That's very true, because as we continue to reduce in big number, the price will go down and it will be affordable. But right now, taking into consideration what we are able to produce now, the price is still a little bit up. But again, it is cheaper than charcoal, which is at times used in urban areas. Slightly, in 3-4 years back, our briquettes were more expensive than the charcoal. It was more expensive than the wood. But as we talk now, it's the reverse. Our briquettes still retain the same cost, but the price for charcoal has almost doubled. And unfortunately, the hardwood that used to produce the gold charcoal is almost gone. So they just cut anything they come across, burn it to produce charcoal. So the charcoal is not all that gold as it used to be some 10, 20 years back. But, and for our briquettes, it is standard because we blend it. We put the same amount of coffee, same amount of rice, same amount of wheat. We have a blending system, we have a formula, we have a formula we are putting ourselves, which makes our briquettes very standard. So I think it's more advantageous right now as we talk to use briquettes rather than use charcoal or wood. Is that clear? Thank you.
Thank you. Okay, thank you. So the question is about the cost of geothermal systems. and particularly because of the actual kind of physical complexity of laying the ground loop, whether the cost of geothermal systems will come down ground source heat pump systems will come down as quickly as the cost of other renewable energy systems.
Well, I think I'd like to answer our question by telling you why we are where we are in the marketplace. We do very few small systems, because you're absolutely right, small systems are expensive to install. There's no doubt about it. We as a company do large systems, and the economies of scale are the single biggest thing in ground source that affects cost. So as we get into much larger systems, the economies of scale really do multiply on themselves. So if we're going to a bar conversion and drilling one borehole, that's a totally different economic prospect to going to one you change and putting some pipe in the pilots, as you saw in the video. And so by focusing on those larger systems and driving the economies from those larger systems into the smaller systems, because if you've got a drill rig which is just going from one house to the next house in a street, then again you've got those economies of scale. And that's where I think the dropping of the price will come from in the market. So it's coming from the large scale down to the small scale. What I would say is that if you benchmark the price of ground source against the other common renewables at the moment, with the possible exception of biomass, certainly on the large systems, we are less expensive, actually. Particularly, this Patrick reminds me, when we are doing some form of cooling as well in large commercial buildings, because you're replacing not just a boiler, but a boiler and conventional cooling equipment also.
Okay, the question is, can the London electricity grid handle all these new heat pumps?
Well, given that just look at cooling, for example, given the efficiency that we're achieving in cooling is twice what conventional cooling equipment has, or we're using half the amount of energy, then yes, provided we pick the buildings properly. So if we're looking at large heating demands, then maybe that's something, or on the road, then maybe that's something that will become important in the future. But certainly the main ambition is to replace all of the cooling buildings with thatch. Then we've got more than enough capacity to do that.
Okay, can we just thank all the presenters from this session? Thank you very much indeed.